Example 2, we want to find the linearization of the function f of x, which is equal to the square root of x plus 3 at a is equal to 1, and then use it to approximate the numbers the square root of 3.98 and square root of 4.05. Are these approximations overestimates or underestimates? Okay, so first thing we need to do is, in order to find the linearization, we need to find the derivative of this function, which is f of x, which is equal to the square root of x plus 3. And we know that we can rewrite this as x plus 3 to the 1/2. So now when we take the derivative of this function, f prime of x, we're going to have 1/2 times x plus 3 to the negative 1/2, which equals 1 over 2 times the square root of x plus 3. Okay, so what do we know? We know that a is equal to 1. So if a is equal to 1, that means we want to find f of 1. We're going to plug that into step 1, which is that function. So f of 1 is going to be the square root of 1 plus 3, which is the square root of 4, which is equal to 2. And then we want to find f prime of 1, so we're going to plug 1 into the derivative function. So that's going to be 1 over 2 times the square root of 1 plus 3. So that's 1 over 2 times the square root of 4, which gives us 1/4. So what that tells us is that we have our ordered pair at 1 and then 2. And then this tells us that our slope, f prime of 1, is equal to 1/4. Okay, so now what we're going to do is we want to set up our linearization. So that means L of x is going to equal f of 1 plus f prime of 1 times x minus 1. So let's go ahead and substitute our numbers. We know f of 1 is 2, plus we know f prime of 1, which is the slope, is 1/4, times x minus 1. So we end up getting 2 plus 1/4 x minus 1/4. So we end up getting 1/4 x. And so this is 2 over 1, which becomes 8 over 4. 8 over 4 minus 1/4 is going to be positive 7/4. So therefore, there is the linearization function here. So now that we've found the linearization function, we want to be able to use it to approximate the numbers the square root of 3.98 and the square root of 4.05. So if we take a look at the first one, the square root of 3.98, okay, you can see here that this is x plus 3. We're going to set it equal to 3.98. So x plus 3 is going to equal 3.98. And then we're going to solve for x. And if we subtract 3 to both sides, we get 0.98. And now that we found x, we can then plug it in to find the linearization. The linearization of 0.98, we're going to plug it into that function, which is going to be 1/4 times 0.98 plus 7/4. And so therefore that becomes 7.98 divided by 4. So the linear approximation, let's go ahead and do that. We're going to take 7.98 and divide that by 4. Gives us 1.995. And then we're going to do the same thing here to approximate 4.05. We're going to let x plus 3 equal 4.05. If we subtract 3 to both sides, we get 1.05. And now we're going to plug it into the linearization function, which is L of 1.05. And then we're going to plug it in. So it's going to be 1/4 times 1.05 minus or plus 7/4. So that gives us 8.05 divided by 4. So let's go ahead and do that. So 8.05, divide that by 4, gives us 2.0125. Okay, so we can see that the approximations gives an approximation over an entire interval. So let's take a look and see what this looks like on the graph. So we're first going to go ahead and graph our function, which is the square root of x plus 3. Okay, and then we're going to graph the derivative function, which is 1/4 x plus 7/4. Okay, so let's see what's happening here. So we have a value here at 1, 2. Okay, let's see if we can get a closer look to this here. So let's see, -3. Let's go to 4. All right, so if we take a look at this graph, this can confirm our results. So we know the red represents y, which is equal to the square root of x plus 3. And we know that the blue represents the function L of x, which is equal to 1/4 x plus 7/4. Okay, so this is illustrating our linear approximation. So we see that indeed the tangent line is a good approximation to the given function when x is near 1. We also see that our approximations are overestimates because the tangent line lies above the curve. So we can see that the tangent line is above the curve. And then, of course, our calculator could give us approximations for the square root of 3.98 and the square root of 4.05, but the linear approximation gives an approximation over an entire interval.